Good afternoon to all of you. Today we will learn about the wireless network and how to configure the wireless LAN. In the class, you would have already learned what is a wireless network. As you already know, when two or more devices are connected wirelessly for communication, we call that as a wireless network. And with the wireless devices, we have a very good flexibility with mobility, and it's most commonly used inside a home or inside any business environment. And this wireless infrastructure keeps rapidly changing based on the user's needs. Now, there are different types of wireless networks. One is the wireless personal area network, which is limited to a very short range of less than 10 meters. And the protocols that are used in the wireless personal area network is, for example, Bluetooth, Zigbee. These are the standards that are used. And in the wireless LAN, it is suitable for a medium-sized network that can range up to 300 feet. And the common protocol that is used in the wireless LAN is IEEE 802.11. So in this 802.11, there are many standards which operates at different frequencies, which supports different bandwidth. And we'll see those standards a little later. Okay, then the next type of wireless network is the wireless MAN, which is used in a metropolitan area network, which covers a large geographic distance, and it's suitable for covering large cities and districts. And they operate at specific licensed frequency. Then we have the wireless WAN network, which covers very large geographic locations, national and global communication. It is used. Now, these are some of the wireless technologies. Say, for example, Bluetooth, it can be limited to few number of devices which can connect, and it is less than 100 meters only distance coverage is there. And it can support a mesh topology. And it also supports point-to-point topologies for optimized audio streaming. Then you have the WiMAX, which is used in the metropolitan area network. It covers up to 30 miles or 50 kilometers. So that's a maximum distance it can cover, and it's a broadband connection. And you have the cellular broadband, which is used in your mobile phones, in your laptops and tablets. And we call that as a GSM, Global System of Mobile, which is internationally recognized. And the type of multiplexing that is used in the cellular broadband is the CDMA. You would have already learned about TDMA, FDMA, and here CDMA is used. And also the satellite communication you have already learned in the first module. Here, directional satellite dishes are used to connect to establish the connection, and it needs a clear line of sight for transmission. And wherever you cannot use wired cables, especially in rural areas, this satellite broadband connection is used. Now, these are the various wireless LAN standards. IEEE 802.11, 11A, 11B, 11G, N, AC, and AX. Now you can see that they operate at different frequencies, and the bandwidth each of them provides is different. Some of them are backward compatible. Some have single antenna, some have requires multiple antennas for input and output. So multiple input, multiple output technology. Okay. And then these wireless devices operate in the radio waves, and the frequency range. Sir?
Yes, ma'am.
Yes, sir, you have raised the hand.
No, ma'am. No, ma'am.
Okay, okay. So all the wireless devices operate in the radio waves frequency, and these are the frequencies at which these IEEE 802.11 standards operate, either in 2.4 gigahertz or in 5 gigahertz. That is ultra high frequency or super high frequency. Now, to govern all these devices that are manufactured by different vendors, there are different organizations. So you should remember these organizations. One is ITU, International Telecommunication Union, which regulates the distribution of the spectrum to different vendors and the satellite orbits which has to be used for transmission. Then you have the IEEE, which again takes care of the different wireless standards. And you have the Wi-Fi Alliance, specifically for monitoring the wireless LAN, that is the Wi-Fi. And to connect any devices wirelessly at home, normally we'll use the NIC or the wireless adapters, and using so that is incorporated with both the transmitter and a receiver. And with these devices, we are able to connect the end devices. Now, if your devices doesn't have an NIC card inbuilt in it, you can go for a USB based wireless adapter for establishing the connection. Now, when you have multiple devices which have to be wirelessly connected to form one local area network, we can go for a wireless home router. So this home router allows you to connect multiple end devices wirelessly. And also it can act as a router to connect with other networks. And so this wireless router can act as an access point. It can connect with other wired devices also. So it supports both wireless as well as wired connections. And also it can provide a gateway for these devices to communicate with the devices of another network. So today's lab, I'll show you how to make use of 3 devices. One is the wireless home router, another one is a wireless access point, and then the wireless LAN controller. So with these 3 devices, I'll show you the demo. Now, what is a wireless access point is, this is for used for connecting a local area network wirelessly. So all the wireless clients can connect with this access point. And what is required in this is both, there has to be an authentication. Only not everybody can attach with an access point. So first step is they have to authenticate, and then only the association will get established. So for which we have to set the agree upon a shared password among all the devices and the access point. The next one is, so in the access point, when we use, there are 2 types of connections. One is the autonomous access point, and then another one is the controller based access point. So in autonomous access point, we have a standalone devices connect with the access point, and they are managed manually. That means you don't have a specific controller to connect all these devices, but individually these clients can connect with the access points. Whereas in the controller based access point, so there is a controller, you can see here, which is configured to manage all these wireless clients. Okay, so here you have a wired infrastructure. In that, there is a controller based access point, which can remotely configure all these devices. Whereas in this case, all these devices are manually configured and they connect with the access point to connect with the rest of the network. So this side forms the local area network. Then there are different types of antennas that are used in all these devices. One is the omnidirectional, which provides 360-degree coverage, suitable to be used in houses and offices. And directional antennas, they focus on a specific direction. And then the other type of antenna is having multiple input and multiple antennas which can be used for input and output. So the bandwidth supported by this MIMO is high compared to the other types of antennas. Now, the topology modes that can be used in a wireless LAN is ad hoc mode, where clients directly connect with each other in a peer-to-peer manner without any access point. This is called as an ad hoc mode. The infrastructure mode is where all the clients connect with the access point, which are then connected using a wired medium to the rest of the network. So here you can see on the left side, there is a wired network, and then you have a wireless network, and these wireless and wired are connected using a wireless access point. And then you have the tethering, where using a mobile phone as a controller, the end device, that's a laptop, can be connected to the internet. I think many of you would be familiar with this tethering topology mode. So in any of the topologies that we have discussed, the two important things have to be looked at. Okay, one is the basic service set, which is actually an identification name given for the areas covered by the access point. Okay, so we have to assign a name for the areas, which is, so it's an identification for the devices which are residing within the proximity of the access point. So suppose if you want to extend it to another LAN, then in that case, we have to go for extended service set. So a union of two or more basic service sets interconnected by a wired distribution system is called as ESA. Now, for the demo, we will be using the basic service set to connect the LANs. So when I do the configuration, I'll tell you. Now, you have learned in the module 5 about the multiple access protocols for avoiding collision, right? So you have already have learned about CSMA bar CD, which is used in the wired medium collision detection, whereas in the wireless medium, collision avoidance is used. Where any device, because air is the medium, and it's very unreliable. So therefore, devices, before they transmit, they have to listen to the channel to see if they are busy or idle. So they send a ready to send message to the access point asking whether is anybody else using the medium. So if nobody is using it, access point will send a CTS message granting the other clients to send the data. Okay, so using RTS and CTS signals, clients get the approval from the access point to transmit the data so that the collision doesn't happen. And all the transmissions are acknowledged so that the sender knows that the receiver have received the message. Now, so to get an association between the wireless client and the access point, these are the 3 steps that has to be done. First one, every client who wants to connect have to discover whether is there any access points or not. If they are available, they should be authenticated with the password. And only after authentication, the association with the access points will get established, after which the data transfer can happen. And so these are the 4 parameters which we will be setting in the configuration. So first thing we have to set is the service set identifier, the password, and then the network mode. Okay, so network mode is which type of wireless mode we want to use. Okay, there are different standards, each providing different speed at different frequency. So any of the modes which we would like to use, we'll use it, because some of the modes are available only in legacy devices, some are available in advanced devices. So when we do the configurations, I'll show you. Then the security mode, for encrypting the data, we have to use the wireless protection access protocols, or wired encryption protects privacy protocol. So we have to enable what type of encryption algorithm do we want to enable. That has to be selected. And the frequency channel bands which you would like to use also can be selected. But the 4 mandatory steps that we have to do is the first 4 steps. Then to discover the access point, there are two modes, passive mode and active mode. So in the passive mode, the access point will broadcast the service ID. So this is an ID that we set uniquely for that LAN. So the access point will send a beacon signals with these IDs. So whoever comes closer to this access point can get connected. So this access point will send the service set identifier as a beacon frames. So it is continuously, it keeps on sending, and whichever client comes closer to it can authenticate and associate. In the active mode, the access points will not send any beacons, but the client should know prior itself what is the service set identifier and then initiate the connection, so authenticate connection. Okay, so here the access point will not send any beacons, but the client who wants to connect with access point should prior know what is the service set identifier and then initiate the connection establishment. After which, once it is successfully authenticated and all the security settings are verified, the connection will get established. So now to do the configurations, we'll be using the GUI on the wireless device. So this is one snapshot where it shows how we choose the security mode, and then how do we choose the encryption algorithm to be enabled, and how we set the password. Okay, so now I'll go to the configuration using the Cisco Packet Tracer. Can you all see the Cisco Packet Tracer?
Yes, ma'am. Yes, yes, yes.
Yes. So now I'm going to use, first of all, I'm going to create a LAN using a access point. So let me take a PC and I'm going to take a smartphone and a tablet. And here you can see wireless devices. There you can go and take access point PT. So this is the device which I'm going to use. Now, as soon as I kept the access point, you can see these two wireless devices automatically connected. The reason is this is sending a beacon with this ID, default SSID. And these wireless devices have connected, whereas this PC doesn't have a wireless adapter in it. It has only a NIC card, Ethernet card fixed in it. Therefore, it is not connecting. So how do we make this wired interface, the NIC card? Here you can see the LAN port. How do we change this Ethernet port with the wireless adapter? So you can switch off the device. You can see the power button here. After you're off it, you can drag and bring the device out. And this is the wireless interface. Wireless interface suitable for wireless connection. So I'm going to drag and drop it in the slot here, and I'm going to switch it on. So as soon as I switch on, now this PC is having a wireless adapter in it. Therefore, it is able to establish the connection with this access point. So now if I keep a cursor on top of this, you can see that automatically an IP address is set, which I did not set. Okay, so this is one of the private IP which is assigned to all their end devices. But I don't want to use any of this automatically received IP address. I want to use my own address. So say, for example, I want to use the address 192.168.1.0 network for this wireless LAN. So what I'm going to do is I'm going to manually enter it. So for one LAN, I'll do manually, another LAN dynamically, I'll show you the answer. Okay, so let me go to static and I'm going to set the address 1.2. 1.1, I'm going to keep it for the gateway. So it says the default gateway will be used for the functional ports. I'm saying okay. And for the tablet also. Now for the access point, I'm going to give, so in the access point, you can see port 1, okay. Port 1, here you can see the service set identifier. So I'm going to give a name for this wireless LAN. I'm giving the name as CSE, and I'm going to set the password, okay. So this is the privacy key, which I'm going to use for all the clients who are going to connect with this access point. So you have to give 10 characters. So let me just give this number as the password. Now this access point is not going to send the beacon. The clients who wants to connect should know the the key. Okay, now in the PC, you can see wireless. So I'm going to give CSE here. As soon as I gave this SSID as CSE and then password, you can see that the connection got disconnected. Earlier it was there with the old IP, but now for this one, it is not there. But once I give the password, key and the SSID, now the PC will get connected. So you can see that it is getting connected. So for the I think the password is wrong. Okay, so it is getting connected. So all the devices are now able to connect with the access point. Okay, now I have a wireless LAN where all these clients knowing the password key, they are able to connect with the access point. Now, I want to connect this wireless LAN with an wired network, which we saw the infrastructure model. So for that, I'm going to create a wired network, which you are already familiar with. So I'm going to I'm going to have a router. So the topology is going to have both a wired as well as a wireless devices. Okay, so they all are the same network. So the wired is also there, wireless is also there. So let me give the address quickly. 1.7. So I've given the IP and the gateway. And let me configure the router interface. So now if I ping from PC to router, I'm able to ping. If I ping from here to this wireless LAN also, I'm able to ping. From this PC to this mobile phone, I'm able to ping. So now you can see a combination of a wired and wireless LAN. Now I'll show you the same topology, how to use a home router. Home router meaning a wireless router. Which has wireless devices as well as the wired devices. So let me add a wireless router. So this is the home router. So a router can connect 2 or more different networks. So we have to yeah, let this PC be a wireless PC. So let me change it in the physical mode. Okay, now it is connecting and it has got a default address 192.168. I don't want to use that address. I want to use say another address, say 10.10.0 network. Okay, so this is the address I want to use. And from this home router to this switch, I want to use this address. So now I'm going to configure the PC. Okay. PC, I want to dynamically get the IP address, so I'll not configure it. So now I'm going to configure the home router. So in the home router, there is no CLI. So how do I configure? You have to go to the GUI. So this is the window I showed at the PPT for configuring the home router. So here I'm going to use the DHCP for all the clients who are going to come closer to this home router. So now I'm going to give the IP address for this router. So my address, which I'm going to use 172.16.10.10. And this DHCP is enabled. Now I'm just saving it. Save the settings. So now you can see the DHCP pool addresses also have changed once I saved the settings, which is at the bottom of the screen. Then we can go to the wireless mode and what frequency we want to send, what is going to be the SSID, the network mode, what we want to use. So the network mode which I want to use is N only. I don't want to use the legacy mode. I want to use the mode wireless N only. Then let me give the name as a Karunya as the SSID. Now this is another LAN. Okay, so the SSID is different. And SSID, I'm saying that broadcast it. Again, the access point, we did not broadcast it. Here, we are broadcasting so that any client, that means this home router is going to send a beacon and whoever comes closer to this will try to associate and authenticate and then associate. Save settings. Then wireless security. Wireless security. Which protocol do we want to use? So I'm going to use the Wi-Fi protected access to personal. Okay, so where it uses the advanced encryption standard protocol, AES algorithm for encrypting the data. So password. So I'm going to use Karunya 2024 as the password. Then I'm going to save. Okay, it needs minimum 8 characters. How many characters? So once I have saved this, okay, I'm done. So the essential steps we have completed. SSID is done. Network mode we have selected. The security algorithm we have selected. That is WPA2, where AES algorithm is used. Now we can go to the PC. See, you can see that using the DHCP now this address it has received. Okay, so you can see that this PC have received using the DHCP, it has got the address 10.100. So for example, let me bring a tablet here and place it. And it has connected. And if we see the address, you can see that the next address in the DHCP server pool is assigned to this laptop. Tablet 10.1.101. And if I bring any other device, wireless device, and I place it here, it will get the next address in the pool. Yes, it has got is 10.1.2. So we have on this side one network and this side another network. So if we try to ping within this LAN, we can see that it is successful. Now the next device which I want to show you is the controller based access point. So now I'll take that device. Okay, I'll take this device, controller based access point, and I'm going to connect this with the switch. And it is part of the same network, that is 192.168.1.0 network. So let me give one IP for this device. So to assign the IP address, you can see that there is no desktop here. So where will I give my IP for this? You have to go to the management tab, and here you can see the IP address. So let me give an address, one usable IP address. I'll give a number 200, and the gateway is going to be the same, 1.1. So the gateway I've set. Let me ping from this PC to check whether I'm reachable to this 1.200. Okay, so now I'm able to reach that wireless LAN controller. So let me go to the web browser. It's not coming. So we can. Okay, 1 minute. Let me try with another device. Can you find any mistake I made setting the IP address? I need to do. Okay, with this controller, I'm able to ping successfully. Let me proceed with this itself. .168.1.220. Okay, let me wireless controller. me give the SSID and check whether I'm able to connect. HTTP slash. Sorry, 220. Yeah. Just before the class, I tried it worked wireless LAN controller. Why it's not working now? Okay, maybe in our next class, I'll show you this wireless controller. Okay, so I don't know why it's not working now. Next class, I'll show you how this works. So if you have any other doubts, you can ask in the chat box. I hope you would have understood the wireless access point and then the home router. This controller based access point, I'll explain in the next class. Okay. So with this, I'll stop for today.